So, moving along, our next speaker is Damir Bogdan. He's the Chief Strategy and Alliance Officer at Quantum Basel. He's going to share a perspective on quantum meets AI, unlocking the next wave of maritime transformation. Welcome, Damir.
Thank you, Chris, and it's an honor to be here. Hello. I also want to thank Malak and Olivier for making this conference possible. It's really great as far as I already saw, and Elvira's presentation before is a perfect segue of what I am talking about. And yes, I know talking about the wave perhaps in a port environment is not the best thing to do, yet when I heard John talking about storms, I can say perhaps the wave is a little bit smaller, but let's dive in. First, a couple of words about us, Quantum Basel. We are located in Switzerland, in Basel, as the name already shows us. At the left side, you see how our campus looks like and will look like. We are perhaps a little bit special in this world because we are completely privately invested with a fund of 500 million Swiss francs, so about $600 million, in order to do something against the potential deindustrialization of a nation. And within that, I've developed a strategy as a CTO for the campus, where we saw that the combination of quantum computing and AI, this was 4 years ago, will be predominant, and therefore we founded Quantum Basel, which works exactly on this crossroad. So let's dive in. And when you start perhaps only looking at AI, then we are pouring perhaps billions in the wrong AI bet at the moment, because the real breakthrough won't happen with these large language models. The real, but from robust near data systems and targeted integration of AI, in some cases also with quantum computing. And so experience with our industry partners show that after the initial wow of starting an AI project, this is the campus, and thank you that somebody showed me that I did not. Thank you. So this is the campus on the left side, and this is the crossroad between AI and quantum. So when I talk about AI only, then we see that many pilots with AI only are fizzling out due to cost, shifting data, hallucination, security, we heard a lot about that, and sometimes also legal issues. So we have been looking forward, where are the real measurable return of investments for executives when you use AI? And we are talking about a hybrid intelligence, not about a monolith. We are combining modern AI with quantum computing or quantum-inspired approaches and methods in engineering. And perhaps I also should have mentioned that on the campus, we are running our own physical quantum system. So we've got a quantum computing. I'm sitting, my next floor below me on my office is a quantum system, and I will also talk a little bit more about hardware later. So, but here with this AI, I'm not talking about linear structured data sets, but about complex data patterns which are not structured, fuzzy data. And this is what we have to use. And this is what we have to use when we are talking about time series data. Then something which you really want to look forward to, there perhaps a point-to-point direction isn't the right thing to go. And you look at energy load forecasting, this is difficult to classical system due to the sudden demand spikes or limited data quality and the need of the multi-scale forecasting. And therefore we came up with a solution which is a little bit more. Yes, we are talking about solutions for, we are in Basel, so precision medicine is something very important, but also predictive maintenance, which we just started with Bosch Digital in the term of simulation, but also as well something like that is important in the port environment, and I'm talking about optimization and simulation. So at the end, it's about scalability and the simulation of non-linear circumstances. And this is something which I want now to focus for the next 10 minutes. First of all, when I say that we are not just a monolith, but we want to combine different kinds of approaches, then if you just look at the classical statistic model, we know them since decades. They are very well known, they are efficient, they are great for linear and structured data. Yet, when you deal with forecasting and optimizations, we often focus on getting just a single number. Let's say the energy consumption for the next day is 112 megawatts. But instead, if you could say that with a 95% probability, the energy consumption for the next day is between 110 and 112 megawatts, you can use this kind of intelligence more and better to think in scenarios. So in the real world, this kind of uncertainty matters, and market shifts, weather changes, systems behave dynamically. And this is where we start with probabilistic computing, which allows us to quantify this uncertainty instead of ignoring it. So we don't just predict one outcome, but we predict a range of possible outcomes. And so at the end, probabilistic computing helps us model and quantify that uncertainty, as I just pointed out. Instead of guessing, we can manage risk more intelligently. So we've got statistical models, we've got probabilistic computing, and now we've got AI. AI is great for scalability and nonlinear conditions, as we heard before from Elvira as well. It's perfect for complex data patterns, but now here comes the point where classical computing can handle perhaps many of these problems up to a point, but once that the number of combination explodes, what we shall call combinatorial spaces, even the best supercomputer today reach their limits. And so this is where we are now behind the statistical models, the probabilistic computing, the quantum computing, where we start to do so. So these four models combined brings then something which we think would be really the next wave, because if you think together with this dynamic forecasting models, with the probabilistic ones, with the scalable AI, and combine all these models together with quantum computing, then this is something where we should build a solution around. And this is exactly what we did. This is where Quantum Basel is at the moment starting, and the combination helps us. We are still facing, we heard that from these hardware limitations from quantum computing. So if we create, and if I put an anchor in your mind, then the anchor is a hybrid model. And so we've built this on the intersection of this, and we call it a meta-learning approach. So we are training on 4 different kind of models, and one customers we've used this kind is Hermes Logistics from Hamburg in Europe. And there it was about the package delivery. How many packets will have to be delivered for the very next day on 4,000 different places within Europe. And so at the moment, we outperformed the classical ones with 24% already. So, shall we call it a day? There's one more thing, and Chris knows I've spent perhaps too much time in Silicon Valley, but imagine that we have to optimize port processes. There is a problem. Most organization algorithms use all input data like ship arrivals, container demand, truckload time. This is a perfect plan, go for it. The reality, though, looks completely different. Late arrivals, technical problems, etc. You have to need the adapter plan, and this is where many AI fail. And yes, sometimes we also do not know the tariffs, but I think not even a quantum system of the future can predict what will happen in there. So, but coming to the next point then. So when we've got an optimization of a port process, then we should start, as an example, with an AI agent. And we can say these are now the spaces of possible solution, like a route optimization. So the agent receives a reward when it goes from one point to the other, finding an optimal path. This was like the game Go has been developed. The AI learns by playing on its own. This is useful for the type of problem, but when the decision space becomes very large, then it takes longer and too long to find this optimal solution. So when we use this kind of quantum of this large models, then today's hardware does not compete or does not bring us a really good solution to this kind of problem. And this is why we try with another approach. We start this with quantum-inspired reinforcement learning. It's more a kind of a try and error approach, where we increase the number of potential solutions, not to endless, but so that the quantum computing can tag in. And you see the quantum states there a little bit with the arrows, but when you use a quantum-inspired AI agent, then there has the ability not to perform sequentially, but in parallel. And this makes the difference. So as soon as the space gets bigger, you don't have to do this sequentially anymore, you have to do this in parallel. And this is what's happening then with this quantum-inspired approach we are using. And now, taking the same customer, we are no more talking just about packets delivery. Well, we see today in logistics about 20% of the trucks drive around empty. And so our next goal is that we need a real-time solution to avoid half-empty or empty trucks. And this is what we do with our quantum-inspired reinforcements approach. And yes, this kind of approach has also then its own dashboard. It has to come into a dashboard where you can really, again, optimize and use your intelligence in a way that you can predict these kind of scenarios when you combine all these kind of different technologies. So to summarize...
Hi, everyone. Welcome to our Innovation Campus, Uptown Basel.
I
am Paula, your friendly artificial intelligence assistant.
We, in fact, have a hologram. Paula is real, if I may say so. She's as big as I am, and she can answer all questions. There are 4 large language models behind her, and we also use her for first customer interactions for some of our customers. But when I want to summarize what we are combining different kind of quantum hardware approaches. So I already said that we've got a physical IonQ system, which is at the moment 36 physical algorithmic cubics. And within 18 months, we will get delivered the next system, which will be a 256 algorithmic cubic system. Then this is accompanied, because it's not just one hardware, with 500 NVIDIA GPUs. At the moment, it's 200 H100s, and then they will be now delivered H200s. And we combine then about 20 quantum physicists, AI specialists. We've founded, together with the local University of Basel, the Institute for Quantum Computing and Quantum Coherence, with already 8 professors in it. So when it comes to student exchange, when it comes to the future generation, this is very important. We've got our own accelerator with Kind Ventures, where we fund about 150 million into startups in the field of quantum and AI. Globally, they just opened in Singapore and in Japan and in Calgary, so expanding quite a lot. And you see, we bring together this kind of thinking, this kind of models into one campus, into one company, and we are looking forward then to see what we could do with this kind of approaches to you. So my goal was to show you that it's not just about one technology, it's the intersection of different kind of technologies which then brings the rubber to the ground in a way that it will really be the next wave. So thank you for your attention.
Thank you, Damir. It's enlightening.